Welcome back. We are continuing to read the KNR, the C programming language, and we're on to section 1.5.3, line counting. Let's jump in. So the next program counts input lines. As we mentioned above, the standard library ensures that an input text stream appears as a sequence of lines, each terminating by a new line. Hence, counting lines is just counting new lines, totally. It has a nice direct symbolic representation. So let's take a look at writing out this script for practice. Include standard IO, int, main, and we'll declare an integer C and another integer NL, which I think is short for new line here. Although in some sense it's not really a new line, it's a new line count. Maybe we'll rename that at some point. All right, so let's go while C being bound to whatever we get from get char, and then checking if that result, immediately checking if that is equal to the end of line character. Now if it is, we continue the loop. Now if the character is exactly equal to a new line character like that, we're going to do something. What we're going to do is increment new line. Get some formatting going on here. New line plus plus, and then for where they've got this is right outside the all of that template stuff. %d, new line character, which we were actually just looking at in a different sense. And let's change this to new line. That just seems, well, it's more verbose for sure. It seems to stand out, I think, a bit better. And for that matter, we've also got the C character. Maybe we should just also call that character for explicitness. All right, so let's compile our program. We've got GCC, and we'll pass in the example 0.c file name, and we will direct that to be compiled into example 0, and we'll run example 0. Now you can see when I have started running this, nothing seems to happen. In fact, even new line characters don't seem to do the trick. However, if I go Control D, that will send a new line character, and it will count the number of new lines, which in this case is naturally 1, 2, 3, 4 new line characters. Great. So that's pretty straightforward, and that's actually one thing I learned since the last video we recorded, where I wasn't quite sure how you were supposed to exit out of that loop at this stage, right? If I hit Control C, I'm actually telling it to kill the program, which is not exactly what I want. I actually want to send a new line, an end of file character, sorry, which is Control D. Okay, so that's a little tidbit I just learned. You might find that useful as well. Now let's get on with the next piece here. The body of the while now consists of an if, which in turn controls the increment plus plus NL. The if statement tests the parenthesized condition, and if the if the condition is true, executes the statement or group of statements it embraces that follows. Now, I guess that's one downside if I go ahead with like renaming characters as I see fit, is that they're not going to match the example. But hopefully this example was sufficiently short that it's not actually that difficult to see that C is character and the new line count is NL in the original example. Now the double equals, equal is the C language notation for is equal to, like Pascal's single equal or Fortran's EQ operation. This symbol is used to distinguish the equality test from the single equal that C uses for variable assignment. Now, a word of caution, newcomers to C occasionally write equal when they mean equal. I mean, yeah, I've done it. I've even done it in Python, long since past being a novice in Python. It's just a simple typing mistake that can happen. As we will see in Chapter 2, the result is usually a legal expression, so you will get no warning. Totally. So A character written between single quotes represents an integer value equal to the numerical value of the character in the machine's character set. I don't know how machine specific that actually is. I would have thought with like ASCII and eventually Unicode that's basically universal, but maybe not. This is called a character constant, although it is just another way to write a small integer. So, for example, single quotes A is a character constant. In ASCII characters set, its value is 65. So it's pretty much universal, because in theory there are more character sets than what I mentioned, but like ASCII and Unicode are the main ones, and even Unicode is actually just an extended generalization of ASCII. So the internal representation of the character A. All right, sure. Of course, A is still to be preferred over 65. Its meaning is obvious, and it is independent of a particular character set. I see. Yes. In theory, if you're using a different character set, 65 could accidentally map to something else, whereas the single quotes A is unambiguously going to be A for whatever character set you're using. It's good to keep in mind. So the escape sequences used in string constants are also legal in character constants. So \n stands for the value of the new line character, which is 10 in ASCII. You should note carefully that the \n is a single character, and in expressions is just an integer. On the other hand, \n is a string constant that happens to contain only one character. The topic of strings versus characters is discussed further in chapter 2. That's fine. Yeah, I mean that can be confusing because there's one character for the \, one character for n, but actually in the table for the character set, it's just one character. So our first example is pretty easy to implement, and the subsequent ones are also going to be quite similar, really. So let's copy example 0 and call it example 1, and we'll just modify it to do a different character. So program that counts new line characters. Isn't that what we just did here? What am I missing? Write a program to count blanks, tabs, and new lines. But that is effectively what this program does. It counts the number of new lines. I must be missing something. So we'll do blanks for starters. I mean, we can say there's basically a blank, a space. Do that first. GCC example 1C -O for directing our output. Example 1 and example 1. Now we'll count spaces. So maybe if I do like this, for example, with actually no new line characters, and then I send that, and then I go Control D, I'll get 1, 2, 3, 4, 5 spaces. I didn't leave an ordinary space. Note that it's not white space, which would include the new line character, I suppose, but it's just a space character, I assume is what we mean by a blank. Now, tabs, we need to look at something a little bit different. Let's copy example 1C over to example 2C. If I was being a little bit less lazy, I would name things accordingly. Actually, just seeing inside of the code, that's going to bother me a little bit if this says new line count when it's actually something more like space. And if I go example 2, likewise, I don't want this to be new line count, I want it to be tab count or something like that. And we'll put in \t like this. And let's compile it. So let's go example2.c \o example 2, and we'll run example 2. It counts tab characters. So I might go ASDF space ASDF, and that should just be 0. There we go. However, if I do ASDF tab ASDF, and then I send new line character, I get a 1. I inserted a tab there. Oh, sorry, it's actually way at the bottom here. Didn't appreciate where I had put my my video. Okay, so if I put in ASDF space new line, I get 0. Or if I do ASDF space ASDF, enter, send EOF, I get 0. But if I go ASDF tab ASDF, enter Control D. I get 1 there, or I could do more. It's very tempting for me to just hit space, but there we go. There's 2. All right. So that's all pretty straightforward, I think. Now let's get onto a program. I feel like this example was really just, these exercises were just doing literally this. I'm still squinting my eyes going, okay, new line. I mean, this is what it did, is it checked, is it a new line character, and it kept a tally. So I'm not sure what the real meaning there is. Now this exercise 1-9 is a different exercise. Write a program to copy its input to its output, replacing each string of one or more blanks with a single blank. I think this is where we need to have like a kind of start, stop kind of character. We'll call this example 3. And how do I want to go about this? Well, we're still going to need to include standard IO, of course, int main. And we might want to still declare like int C, and then whatever symbol we want for basically our blank. Let's just call that, I don't know, BC maybe? Sure. Or maybe let's call it blank. Let's call it int blank. And this is a kind of like counter that we might have to reset as we go along. So let's go while, and we'll bind to see the result of get char is equal to EOF. If it is, then we're done. But suffice to say, if it's not EOF, we're going to continue into this loop. So what do we need to do here? It seems like the first thing that would be natural to do is check if C is equal to the target character that we care about, which is a blank. And then if it is blank, I don't know why I called this blank. Then we'll need something that's kind of like a state variable to say, well, blank, we'll say, I don't know, should we basically increment it? Is that what we should do? I keep saying black. My goodness, blank. So we could increment it. I don't know that we actually need to actually increment it. Just 0 versus 1 is probably fine. Maybe that's what we should do. Do the simplest possible thing rather than do something that is technically going to work. Because all I care about is it 0 or not? So I'll set blank to 1. So let's see. As I'm going along finding blank characters, I kind of want to know whether I need to do like an overwrite, though, you know? I'm just thinking about what's a way to go about this. I think I need something like put char. I'm just Googling here. It's yeah, looking online, there is like a put char function that corresponds alongside of the get char. Char writes a character to standard output. This function is a possible cancellation point. Therefore not marked with a throw. That's fine. Works for integers. And what would I want to do here? I guess one thing we could do is store something like, well, we're setting that this is blank. So we could have a couple of cases. One is that it's not equal to, yeah, maybe we just want to replace it when it's the first one. So if it's not equal to a blank, then we can say that our blank we can check whether this is equal to 1, and that's kind of all we care about is it 1 or not. Because let's see, under this branch we've got whether the current character is blank, and then we've got this counter of whether blank was already 1. If it is, then we'll put char. We'll just put the same char C there. And then we just need to worry about the other branch of or we could just do something like last character. And then we would say, yeah, this is, I think, more explicit than dealing with the emp. Like we're gonna check the actual character. So otherwise, I guess we're just skipping it over, right? Like that's kind of the most efficient thing to do. It's not even to like think about how to replace it. It's just simply to not print. So we don't really need like an else clause to do something because there's nothing to do that we want to do when it's false. I think that makes sense. And then we just need to make sure that we update last character regardless. So the last character can be assigned to C, but only after we've moved past this. Because at the beginning, at the very first iteration of this loop, it's going to be EOF or -1, which means we won't go through this, and then we'll assign this, and then as we go through, it may or may not be. Let's give this a try. I think I still need to return 0. Okay, I'm a little less certain on this example, but this is good. This is where the learning is happening. So let's go example 3, and then let's go ASDF, and then let's put in like 1, 2, 3, 4, 5 spaces, and then ASDF. Go enter. Nope. That did not do entirely what I wanted it to do. Put some spaces in. Enter. No. Something about my program is not actually quite correct, is it? Let's see. And I am getting starting off initialized with EOF. And if it's not equal to EOF, char is not equal to EOF. And then inside of that, I'm immediately checking C does not equal open, or that the last character is not equal to a space. Then I'm going to put char C. That's fine. And then last character, C, return 0. This seems correct. What am I missing? I must be missing something here. So 3. Yep. Okay. I think now we're in business. Yeah. Excellent. Now it's doing it. So the problem there was a problem of that I had misplaced this bracket, and that the assignment of C was actually being assigned to the Boolean of get char being checked against EOF, but I actually wanted C to be assigned to get char, the result of get char, and then check it against EOF. So I messed up my brackets there. Okay. So I think that's good for that exercise. Let's move on to the next one. Example 4.c. Write a program to copy its input to its output, replacing each \t by tab, or sorry, each tab by \t, each backspace by \b, and each backslash itself by \\. This makes tabs and whites and backspaces visible in an unambiguous way. Let's give it a try. So let's see here. Standard IO, main. What are we going to need to do here? Pretty much of a very similar setup. So we'll declare int C, and we'll say while, and we'll try to do our assignment correctly this time. Get char, and we're going to basically need to do a while loop over all of these. So as we get each char, then we can basically check what kind of character it is. Write a program. This makes tabs, sure. Write a program. And it's replacing, but otherwise, if it's not one of these target characters, then I expect that we still put char anyway. So there's going to be like an else clause to put char. If it's not any of the above. So let's start with, I mean, off the top of my head, I don't see why we can't just look at each of these cases immediately in this order. So if we have a \t, then we're going to put char. And what is this going to be? I'm not sure my brain needs a little help here with, okay, multi-char, is that actually a problem? This is going to be tab, but if I put char 2 backslashes versus 1, I don't know that this makes, what difference this makes. Maybe actually, because it's kind of multiple characters, it's not really like a single character anymore. Incompatible pointer to integer conversion. So I think there's a problem there where I'm maybe I should do that. I should print it, because printf does go to standard out, I believe. Right, formatted output to standard output, sure, okay. And then we'll say else if, maybe even just for the moment, let's write our else clause. Let's just say else, and whatever the character otherwise may be, we'll just put it. Standard output. We're not done, but I want to be incremental in trying to solve the problem. So let's just even double check that it compiles and that we're correctly replacing the tab character. So let's put in some tab characters, ASDF tab, ASDF space, ASDF tab, foo, bar, fast. So that does look like it has probably replaced in the sense that the exercise wanted. Something I actually haven't considered for these exercises is maybe trying to find a solutions manual just in case we misunderstand what some of the problems actually are. But that, I think, looks like what it's asking for from the plain wording of the question. So let's throw in an if, else, or sorry, other way around, else, if into the mix. And that expression that we'll put into the else if will be a similar kind of thing if we're going to check for the character that we want to match on. So in this case, we're going to check, is it a \b, or in other words, a backspace character? And we'll just do the same rigmarole there, except we will put in a B. And then what else? We'll also want to grab else if for if C is equal to literal character \\, and we will not use that long printf helper. Let's put in printf, and we'll call it \b, like that. Okay, at a glance, I think that's correct. Let's give it a go. Now, let's try to make sure we put some of each of the characters in. So let's go ASDF tab, and then ASDF backspace, and then tab, put a slash in. So did that get everything I wanted? There's a tab there, and then ASDF tab. I'm missing the backspace. I'm not sure how the backspace would go in there, really. It's a good question. That's a delete character, backspace. Let me quickly Google this. How to send backspace to standard in. Because it's kind of like a negative Control H. There we go. Oh, okay, well that worked. Control H, apparently, is one way you can do that for ASCII 8. Okay. Okay, well, let me see. Did I basically fulfill this? Write a program to copy each of its inputs to its output. The program does copy it, and it does replace these, although it's a little clunky to do the backspace. This makes tabs, backspaces visible in an unambiguous way. Yeah, I mean, it's an improvement in some sense. Okay, well, thanks for watching. I think that that's going to be the end of this video, and we'll pick up on the next section for the next video on word counting. Hopefully you found this video interesting or useful, and I'll see you in the next one.